Hello students. So we'll move on to the last topic of DFA. So that is number of specified symbols, mod K problem. Okay. So over mod K problem, there are 4 different varieties. Fine. Be careful students. Like for the last 3 varieties, mod K problem, like we are using the same formula like Q of I plus 1 mod K. Okay. But previous to that, divisible by K problem is different. Okay. There we are using the transition formula different. Okay, here we are using a different formula over here. Clear? Okay. So now number of specified symbols mod K problem. What exactly it is? Okay. The name only indicates in your question there will be like some kind of specification regarding a particular alphabet in our string. Okay. They may ask like you need to design a DFA which should accept the number of A's mod 3 should be equal to 0. Okay, means in a particular string of a combination of AB, let it be AB. Okay, like DFA, whatever we are designing, right? Okay, it should be able to accept for a such a string which is having multiples of 3 number of A's. Okay, if you are having 3 A's in that particular string, followed by or in any other places, if it is B available, then also no problem. Okay, if it is having 3 A's, then it should be accepted. If you are having like 6 A's, it should be accepted. Okay, anywhere it may be. Okay, it may be like in the beginning, it may be in the last, it may be a mixture of AB combination, anything it may be. Clear? Okay, so such kind of condition will be mentioned in your question. Number of a particular alphabet. Okay, so such kind of problem we are calling it as number of specified symbol mod K problem. Okay, procedure and all everything is same. Okay, how we discussed in the previous mod K problem variety. Same thing we are having. Okay, but we need to repeat this step number of times. That's it. Okay, so that like according to our convenience, fine. We need to simplify our problem. Okay, we need to minimize the complexity over here. For that, we need to repeat few steps number of times. That's it. Okay, so we'll begin. The number of specified symbol, say A in a string W is denoted by, observe it carefully, number of A's. Okay, so that we are representing it by what? Here, n to the base A. Okay, n to the base A stand for what? Number of A's where exactly in this particular word. Okay, n to the base W stand for W is a particular string. Okay, it may be having like combination of AB, or it may be having only A, or it may be having 0 number of A's also. Does not matter. Okay, so if you are writing this time, okay, it represents what? Number of A's inside a string W exactly. Okay, so now let us see what is the general method to solve number of A's mod K problems. Okay, the general method remains same as for string length mod K problem. Okay, so what we discussed in the previous lecture, like string length mod K problem, same type of method we are following. The procedure is repeated for convenience. Okay, we need to repeat some certain steps, okay, multiple number of times so that we can minimize the complexity of the problem. Clear? Okay. What should be the first step? Obvious. Okay. The first step, find the reminders obtained by dividing the number of specified symbol by K. Okay. So what we need to do, we need to find what are the possible reminders we can generate from a value K exactly. Okay. See, if K value is equal to 3, if you are dividing any number it may be, the possible reminders would be what? Like 0, 1, 2. Apart from this, we won't get any kind of reminder. Right? Okay. If you are dividing 1000 by 3, you may be getting 0, you may be getting 1, you may be getting 3. Sorry, not 3, 2. Okay. If you are dividing 10,000, same variety of reminder you are going to get. Okay. So when you are deciding the K value, easily we can identify what should be the reminder. Clear? And what is the use of finding this reminder? Because we need to decide the number of states. Fine. The number of states are depending over the reminder, whatever we are generating using K value. Clear? Okay. So in the step number 1, we are finding what is the K value and what are the possible reminders we may face in our DFA design. Okay. Then later, step number 2, identify the transition. The transition can be obtained using the following relation. Okay. The same formula we are using, delta of Qi I stands for a particular state exactly. Okay, like 0, 1, 2. If the k value is equal to 3, okay, then we are considering the alphabet. We want to check here is a exactly, small a. Okay, so if that is the case, then the transition return will be what? Like q of I plus 1 mod k. Okay, I value should be added with 1. Then we need to apply the mod operation using the k value. Then whatever the remainder we are getting, okay, so that will be the qj value. Qj value. Remember, see this mod function, whatever we are using, okay, so that is for representing the j exactly. Okay, for representing the j exactly. Remember, okay, k is the divisor. Okay, I represents the reminders 0, 1, 2, k minus 1. So this is what the formula like or the representation like how many number of I value we can find. K minus 1 always. Okay, obtained after dividing by q. Okay, so this is what the step number 2 exactly, using which we can easily design the transition table. Okay, so once we are getting the transition table, easily we can draw the transition skeleton, or else a DFA skeleton, what we are following. Okay, okay. Then what will have we need to decide which one should be the final state and which one should be the start state. Okay, by default, like Q0 will be the start state, and the final state, it depends on the question. Remember, okay. See, if this is what the question example we have over here, like language L is equal to, okay, W. W is what? A combination of A, B, or combination of only A, it may be. Let it be, no issue. Okay. So inside this particular string W, okay, we are checking for what? How many number of A's are available? Okay. Then it should be divided by, after finding that how many number of A's, example like 4 A's are available. Okay. See, after dividing it by some particular value, example like mod 4 it is. Okay. Number of A's is equal to 4, mod 4 if it is available, then remainder how much you are getting? 0 exactly. So here 0 will be called as a j value. Means qi on receiving A, okay, it will be going for qj, right? Okay, so this j value we are deciding according to this particular relation. Remember, okay. So from question we can easily identify what will be the final state. Okay, here qj will be the final state. So here we got some samples. Observe here. If L is equal to number of A's, okay, under this particular string, mod k will be equal to 0. Okay, means find the number of A's inside this W divided by this k value. So if you are expecting, okay, remainder as a 0 for this particular word to be accepted, okay, then Q0 will be the final state. If you are expecting the remainder, or if you are designing a DFA which should be accepting the remainder 3, then Q3 will be the final state. If you are expecting the remainder as 5, then 5 will be the final state. So whatever you are expecting from your DFA to accept, okay, so that will be called as a final state. Okay, okay, students. So this is what some brief introduction about number of specified symbol problem exactly. After this, step number 4. Here, step number 4 is not visible. We need to draw the DFA skeleton exactly. Okay, so we'll go for the first problem. We already discussed. Okay, solving the problem procedure will be different. Final outcome will be same. If you are using any kind of a method, does not matter. Okay, you'll be ending with what? The same result. Okay, so draw a DFA. First problem: draw a DFA to accept language L, which is equal to number of A's under W, mod 5 not equal to 0. Okay, mod 5 not equal to 0. From this question, three things we can identify. What are those? The k value we can identify, right? Okay, and the possible reminders we can identify. Okay, or else the number of states. Okay, apart from that, we can call it as number of states we can decide. Okay, and which are the final states? Okay, not also we can identify. Okay, we'll begin. The solution: the language accepted by the DFA can be written as shown below. The same thing we are overwriting. Okay, so not overwriting, rewriting it is. Language L will be equal to number of A's, okay, under W, mod 5 not equal to 0. So that is what the question. So from this, we are identifying few parameters over here, where Q0 is the start state, obvious. Okay, so here we can expect one of the remainder called as 0, because if you are dividing any number by 5, the possible reminders are 0, 1, 2, 3, and 4 exactly. So Q0 will be called as a start state. Okay, in the mod 5 we are having, because of that k will be equal to 5, because it is a divisor, k value will be 5. Then I value the possible reminders or the number of states will be 0, 1, 2, 3, 4, 5 exactly. Sorry, not 5, 4, till 4. Okay. Are the reminders obtained after dividing by k? So we got 3 parameters from this. Okay, we'll go for finding the 4th parameter. Okay, so here they are trying to explain something. Just observe. Okay, it is not the condition which is mentioned in your question. Okay, it is different exactly. If number of A's under W mod 5 is equal to 0, but in our question, not equal to we have, then Q naught is the final state, right? Okay. In the previous slide, while deciding the final state, the J value, whatever we are having, that should be considered as a final state exactly, right? But here, in the place of J, before that, what we are having, the assignment operator, what we are having, that is very important exactly. Okay, sometimes it will be having equal to, sometimes it will be having not equal to. Okay, if you are having equal to, then Q naught will be the final state. But here in your question, they are mentioned not equal to. Okay, then except Q naught, all are final state like 1, 2, 3, 4. Okay, so those 4 state, okay, like Q1, Q2, Q3, and Q4 will be called as the final state over. Okay, then we are having a transition function formula over here. Okay, just start substituting the value of I. Okay, value of i's are 0, 1, 2, 3, and 4. Okay, then finally we are generating the transition table. Okay, just observe how we are generating the transition table. So this is what the table where the first column stands for the I value. Okay, the possible values of I are 0, 1, 2, 3, and 4. Wait a second. So in this question, they are not mentioned the alphabet apart from A exactly. Okay, they see, observe it carefully. They are not mentioned the sigma. Okay, so under sigma, if it is like A comma B, then we need to have a transition for B also. But in this question, they are not mentioned any alphabet. They are just mentioning like number of ways should be found. That's it. Okay, so because of that, we don't have a split in this particular row. Okay, like we are having only one alphabet. We are considering it as we have only one alphabet. Okay, that is for A exactly. So the possible values of I 0. Okay, so delta of Qi comma A will be equal to Q of I plus 1 mod 5. Okay, so this is what the formula we are using to find the transition. Okay, so I value, if it is 0 everywhere, wherever you have a I value, just substitute it as 0. First case. Okay, Q naught comma A will be equal to Q of 0 plus 1. Why? I value is equal to 0 plus 1 in formula exactly. So what is the result? 1 you are getting. 1 mod 5, what is the result? 1 exactly you are getting. Later, next value, Q1. Okay, because 1 is the next value of I. Okay, then 1 plus 1, 2 we are getting. 2 mod 5 will be 2. Because of that we are getting 2. Then next value, 2 exactly. 2 plus 1, 3 exactly, right? So 3 mod 5 will be equal to 3 exactly. Then 4 mod 5, 4 exactly. 5 mod 5 will be 0 exactly. Okay, so I'm repeating it again that see here, whatever the gesture you have for the skeleton, okay, while evaluating, we are not expecting the same gesture. Remember, okay, like from this slide, you can identify, yes, we can draw this particular DFA in this format. Okay, but it depends on the question. Like we will not be having any information like how it may be mentioned in your textbook. Okay, so what you can do is you can start from Q naught. Okay, you can start from Q naught, right? Q naught. Okay, then you can just start like traveling towards the final state like Q4. Okay, there are many number of final states available. There are total 4 number of final states. Okay, like Q naught to Q4, you can draw it like straight line exactly. Okay, later you can observe when Q4 is receiving A. Okay, then we are going for what? Q naught exactly. Then you can draw like this. Okay, name it as A. That's it. Okay, so like this also you can draw. It is up to you. Okay, what kind of gesture you want to provide it for your DFA skeleton, it is up to you. But remember, the transition should be clear. Transition should be clear. Okay, don't mix these states like Q0, then Q4, then Q1, then Q3, then Q2. Okay, then it will be like more complex for you also and for us also while validating. Okay, so you may be having chance of losing marks. Okay, so don't do that. Don't mix your states. Okay, let it be like in single line, no problem. Q0 to Q4, then start providing the transition. That is the better way. Okay, so after this drawing the skeleton, okay, so we are going for the definition of the DFA. That will be M will be equal to Q comma sigma comma delta comma Q0 comma F. Is defined as Q is equal to the number of states like Q0 to Q4. Sigma is equal to A because apart from A, they are not mentioned anything in your question. So alphabet will be A exactly. Then sigma is shown for the transition table. Okay, Q naught is the start state and final state. See, except Q naught, rest of all are final states. So Q1 to Q4, rest of all will be final states. Okay, so now we'll go for the next problem. So previously we had not equal to, but here we have a equal to. Draw a DFA to accept language L, which is equal to number of A's under W mod 3, which is equal to 0. Okay, so the number of A's like accepted by the DFA is what? Multiples of 3 exactly. Okay, if it is multiples of 3, then it will be accepted. Otherwise, it will be rejected. Okay, so here we can identify total 4 different things. One is what? The K value. Later, the reminders. We can decide the number of states. Then the final state and the start state also we can easily identify because equal to sign we are having. So obviously 0 will be the start state and also the final state. Okay. So we are rewriting the language. L is equal to number of A's under W. Mod 3 will be equal to 0. Okay. Then Q naught is the start state. Okay, fine. Let it be K is equal to 3 because it is mentioned in our question. Then I value will be the possible reminders. Whatever we can generate using 3 is what? Like 0, 1, 2 exactly. Right? Okay. Then the number of A's mod 3, which is equal to 0 that we are expecting that our DFA should accept. So 0 should be made as a final state. Then obvious, we need to go for drawing the transition table using a transition function formula. Okay, that is I plus 1 mod K exactly. Okay, then every weight just substitute. So in this question also, we don't have a sigma like A comma B. We have only one alphabet that is A exactly. Right, for this kind of question, they're specifying only one alphabet. Okay, because if you mention like multiple alphabets like A comma B comma C, then we need to mention the transition, different transitions over here. Right. Okay, so you can expect only one alphabet for this kind of question. Okay, so Q naught on receiving A, we are going for Q1 exactly. Then Q1 on receiving A, we are going for Q2. Okay, then Q2 on receiving A will be going for Q naught exactly. Yeah. Okay. Then like using this transition table, we are trying to draw the skeleton of DFA. That is what the start state Q naught. Okay, then Q1, then Q2 exactly, right? Because I values are 0, 1, 2. So 3 states we can get. Okay, so according to the question, we need to make Q naught as a final state also. So we are making it as final state over there, Q naught. Okay, just observe the figure. Okay, the skeleton of DFA. Then Q naught on receiving A, it will change its state to Q1. It is mentioned in our transition table. Okay, then Q1 on receiving A, it will be going for Q2. See, Q2 it is coming back. Okay, then Q2 to Q naught again. Okay, because Q2 on receiving A, it is mentioned that it will be going for Q naught exactly. Okay, so using these like elements, we are trying to specify some parameters over here. Q will be equal to 0, 1, 2. Then sigma will be equal to A. Then delta will be like shown using a transition diagram as shown over here. Okay, then Q naught will be the start state and Q naught is the final state. So, so this is it now. Okay, like DFA problems, we are done with all the 5 varieties of different problem. Okay, like first one was the pattern recognition problem over which we solved around 15 to 20 different problems. Later divisible by K. Okay, then later mod K problems. Okay, then the number of like specified symbols. Okay, mod K problem. See, these are the variety of DFA problem exactly. Okay, you can expect any kind of question in your exam. Okay, so one last topic we are left with, that is what the disadvantage of the DFA. Okay, so because of which we are moving towards the NFA. Okay, non-deterministic finite automata. Okay, so these all the disadvantage whatever we are observing in your like on your screen. Okay, will be recovered or solved under NFA exactly. Okay, so here we got some disadvantages over here. Constructing some of the DFA is very difficult. Yes, obvious. Okay, so we don't have much flexibility when we are comparing the DFA to the NFA. Okay, we don't have much flexibility. Okay, fine. Then the DFA cannot guess about its input. Okay, like whatever the state or whatever the transition we are deciding. Okay, so only those are available exactly. Okay, But in case of NFA, like for one particular alphabet from one particular state, we can have multiple number of transition or zero number of transition also available. Okay, but in case of DFA, such option is not available. Okay, so compared to NFA, DFA is a bit weak. Okay, so the DFA is not very powerful. Okay, at any point of time, the DFA is in only one state. Okay, so a DFA does not have the power to be in several states at a time. Okay, or at once. Okay, so this I will explain. The last point I will explain while explaining the NFA concept. Okay, like the behavior and the working principle of NFA. Okay, after discussing that, we'll be having better knowledge like how it is differ from the DFA exactly. Okay, so these are the few disadvantages what we can observe under DFA. Okay, so from the next class, we'll go for NFA exactly. Okay, we'll solve few problems over NFA. Okay, then after that, we'll go for the epsilon NFA. Fine, and we will be left with two more topics. Okay, so once we are done with that, by the end of this week, okay, we'll be end up with the module number 1. Okay, it's a bit vast. Okay, like the topics are more and problems are also more. Okay, don't worry. From the module number 2, 3, 4, all bit simple and compact. Okay, okay, students. So we'll meet with the NFA the next week. Thank you.